Question 15 says, a cyclist is rounding a 20-meter radius curve at 12 meters per second. What is the minimum possible coefficient of static friction between the bike's tires and the ground? So based on the problem, we can see that we're given the radius and we're also given 12 meters per second. So R is equal to 20 meters, and then 12 meters per second is velocity. So we're given velocity, which is 12 meters per second. Based on this, we can also draw a picture that would help us understand this a lot more. So the radius is 20, and right here, I guess I will draw a little bike. It's as best as I can get it. So that bike, you can also see that it's being pulled inward with the force of static friction. And right here is also Fg, but we will not be worrying about that. So we need to find the values, the sum of all the values in the x direction. So the equation we will be using is sum of F forces in the x direction is equal to mv squared over r. We can tell that we're given both r and v, so we just need to plug in for those values, which is equal to 20 squared over 12 squared over 20, which equals to 7.2. So the forces in the x direction is equal to m 7.2. We also have to find the forces in the y direction, which, based on the problem, it has to equal to 0. So how we do this is Fn, which is what we calculated here. So Fn forces, normal forces, is equal to m 7.2. And it has to equal to mg. So how we solve for this is we just plug it in. So it's mg is equal to m 7.2, which we can divide out the m, and we are left with g equals 7.2, but we need to find out what g is equal to. G is gravity, so gravity is 9.8. So 9.8, then the coefficient for static is equal to 7.2. Let's divide 9.8 by both sides, and the coefficient for static is equal to 0.73. And that is how you solve that.